Good morning to everybody. Today, hydrocarbon alkanes, chemical properties and continuation. In my last video, I explained you different properties of the alkanes, that is halogenation, nitration, sulfonation. Now today I will explain you oxidation. Oxidation means reaction with oxygen or with air. First we will talk about the complete oxidation or the complete combustion and the incomplete oxidation or the incomplete combustion. Complete combustion means when alkanes burn in oxygen, that is sufficient supply of the air or the oxygen. Completely burning of the alkane takes place and form the carbon dioxide, water, a lot of the amount of the heat. Again listen, complete oxidation means when supply of the air is sufficient or it is oxygen, then the alkanes they burn completely to form the carbon dioxide, water and a lot of amount of the heat. In the same way, we take example of the ethane. It undergo complete oxidation, form the carbon dioxide, water and a lot of amount of the heat. Now the incomplete oxidation or incomplete combustion means when the alkanes they did not completely burn to form the carbon dioxide. Here the supply of the air is insufficient or the oxygen is insufficient, then the alkanes they burn to form the carbon monoxide instead of the carbon dioxide and water. Here alkanes did not burn completely and they form the carbon monoxide and water. Or we say that the alkane methane undergo incomplete oxidation, it forms the carbon black and the water. And this reaction is very much important as this carbon black is used in the case of the industries for the black paints and the blackings, etc. So this is the complete combustion and the incomplete combustion. Now we will talk about the controlled oxidation. Oxidation of the alkanes under different conditions they form the different products. First, if we take an example of the methane and oxygen, that is, react in the presence of the copper at 525 K temperature and 100 atmosphere pressure. So here if we take the ratio of the methane and oxygen is with 9:1 and they are heated at about 525 K as a copper catalyst under 100 pressure, it forms the methanol. Here methane forms the methanol. Condition is that ratio of the methane and oxygen is 9:1 in the presence of the copper as a catalyst and 100 atmosphere pressure at a temperature of 525 K. Now if this methane is heated with oxygen in the presence of the molybdenum oxide as a catalyst under pressure, it forms the methanol, that is formaldehyde. Now third condition, if we take the tertiary hydrogen, that is Here if we take the example of the isobutane. Now this isobutane, which contains a tertiary hydrogen atom, when oxidized with alkaline KMnO4, it forms the tertiary alcohol, that is butyl alcohol. So three conditions: in the presence of the copper as a catalyst at 525 K, and if it is heated in the presence of the molten oxide under pressure, and when the tertiary hydrogen atom is oxidized with alkaline KMnO4, three different products. Now these alkanes oxidize to carbonic acid. Suppose if we take the example of the ethane, it is heated with oxygen in the presence of the silver oxide as a catalyst, it forms the carbonic acid, that is ethane form the ethanoic acid. So here different conditions, different catalysts and the different products. Now if you see oxidation of the alkanes in a continuation, methane first form the methanol, then methanol oxidized to methanol, and then methanol oxidized to the carbonic acid. If we take a continuation process of an alkane, methanol to methanol and then to the carbonic acid. So this is the oxidation. Now what is the action of the steam of the alkanes? It's a very important question for the industrial purpose. Methane with the steam when heated at a very high temperature, that is 1275 K, in the presence of aluminum oxide as a catalyst, it forms the carbon monoxide and hydrogen. For industrial purpose, this hydrogen is very much important. So this formation of the hydrogen on industrial process by the action of the steam on the alkanes. Now I will explain you isomerization in the case of the alkanes. You see, higher alkanes, they form their branch chain compounds. Suppose we take the example of the normal butane. When heated at 505 K in the presence of a catalyst, that is aluminum chloride and the HCl, it forms the 2-methyl propane, that is the isobutane. So here normal butane is converted to the branch compound, that is isobutane, and in the same way if we take an example of the normal hexane, when it is heated at about 505 K in the presence of aluminum chloride and the HCl as a catalyst, it forms their isomers, that is 2-methyl pentane and the 3-methyl pentane. So these are the chemical reactions of the hydrocarbon alkanes. In my next video, I will explain you some more chemical properties of the alkanes. If you like my videos, please share and subscribe. Thanks very much.